So hello everyone, today we're going to be talking about SQL being slow. This is a decade-old question, so I also want to answer to this. The thing is that there are multiple reasons why SQL can be slow, and one of the reasons is the OR statement. So let us take an example which will make your understanding clear. So one table is their applications, and the data is 1 million applications, and there are 1,000 users. So what you do, query using OR statement. This is what the query is. So there is a submitter ID and reviewer ID. So we are also thinking that submitter ID and reviewer ID both are actually indexed. I'll say what is the meaning of indexing in SQL in just a second, but this is the query that you're actually doing. Now, if you run that particular data, then what you actually get is this 100 milliseconds of every duration. So you might think it is just 100 milliseconds. I do not bother. This is basically a very simple example, and you can speed up so much. And what you can actually do, there is an alternative query, which is this one. In this case, what it is going to happen, your 100 milliseconds query is going to be converted into 1 millisecond query. There is a 100x improvement. The only difference is that OR is actually not there, and it uses addition and subtraction in order to do OR, which is the same thing here. So how it is doing is basically, let us say this is A, this is B. What you actually want is when this one and this one is there, right? Either this one or this one, A union B. A or B is basically A union B. So what is the formula of A union B? A plus B minus A intersection B. That is quite good, right? This is the thing that is being done here. It is actually 100 times faster. So what is the reason for it being so fast? So let us try to understand why there is 100 times speed improvement in this case. So this is what we're trying to understand here. In order to understand this, we have to understand how SQL indexes actually work. So if you know about SQL indexes, then you should be able to understand this thing. But if you do not know, then bear with me. I will just try to explain it. So SQL indexes, what is actually SQL index? So let us say there is a particular table. The table is T, and it has different columns in it. It is A, B, C. So these are the columns it has. So what is an index? It is of a particular column or multiple columns combined or things like that. What it happens is that if you index this table by the C column, and if you run a where query where C is equal to 1, then it basically looks up into the index that is built for tracking out where the data is actually there in the file, or you can say in the disk. So let us say C equal to 1. This is an index. What happens is that there is 1, there is 2, there is 3, and 1, it has the data pointers. Okay, this is the data pointer. This is another data pointer. This is another data pointer, or something like that, right? If you index by it, then it will have a list of the data pointers where the data is actually found. So most of the times it is B tree, right? So this is the B tree. So whenever you do where C equal to 1, it'll basically search for C equal to 1 here in this B tree. It will traverse down, and in this way it'll search for it. And just by looking at this, you can actually understand why it is actually slow. This is what index is. It is simple, right? So in order to understand this better, why it is actually faster, you can do, like, instead of or, you can just write and you have this. If you execute this query, and if you assume that the column submitter ID and reviewer ID both are actually indexed in this particular table, the table is basically indexed by submitter ID and reviewer ID both. So because of that, what you can see is that when you execute this query, the SQL executor actually first decides which one to actually execute first. So there are two indexes. Assuming that there is no any compound index. Compound index meaning is that this particular thing, it will have for each of the data points, like B is A and C is 1, then instead of C equal to 1, it will have in the pairs A comma 1, and for that particular thing it will have a list of data pointers, right? It is in the way. So for compound statement, it is basically the same as this one. The whole compound statement is going to work here, right? In the case of and, it is very and friendly as well if you have a compound index. But if you have not, we are looking at this condition. If that is the case, what it happens? In this case, what it happens is that the SQL executor is actually going to take a decision to look at this one or this one first. Let us say that it looks at this one. But the thing is that if a particular index is chosen, and if the index has a lot of data pointers, then it is not going to be helpful, very helpful. So the thing is that the first index that the SQL executor actually selects should be the smaller one. So if it selects this one and there's a smaller number of data pointers, then it's going to be super cool. It's going to be super easy for the SQL to actually determine where the final data lies and extract the data from there and execute the query. But in the case of OR, it is really difficult to find this out, right? In the case of OR, it is basically tricky. We do not know because either it is submitter ID is this user ID, either reviewer ID is user ID. So it is going to be hard. So this is a better approach in order to execute the SQL. So this is why OR might be slowing you down.